What's up, mobile devs? Today we are going to recreate from scratch the scroll behavior by using just a PanGestureHandler. And in order to do that, we are going to build together this simple animation. So here we can actually see that the animation is pretty straightforward to achieve with a scroll view or a flat list. But in this specific example, we will just use a PanGestureHandler with a bunch of animated views. So this is actually a tutorial meant to be instructive, but the truth is that in the reality there are a lot of use cases where it is actually needed to have more control about your translate text values, about your pages and your shared values. And therefore it is often needed a re-implementation of the scroll view with a PanGestureHandler. So remember that all the source code, it is always available on GitHub. And let's start actually to dive in some code. Here I have created a React Native project using Expo CLI. So I've already installed, as always, the React Native Reanimated package. 3 days ago they released the version 2.2.0. But anyway, if you want, you can use any version above the version 2.0. Since we need also the PanGestureHandler, I've already installed the React Native GestureHandler package. And of course, don't forget to add the React Native Reanimated plugin in the bubble config.js in order to enable the reanimated worklets and the reanimated hooks. So I think we can already start to define our titles. So I will just write "What's up, mobile devs." So you can use whatever strings you want, of course, and we can define the pages of our fake scroll view by mapping actually the titles. So let's return a view. So we need actually to provide a key to our view. So let's say index to string. So here we go. This view right here will be our page. We will do a lot of things with the page of the scroll view. So I think it is a better idea to create a specific component for the page. So let's create the components folder and let's specify the page.tsx component. I will use as a React Native snippet just to be a little bit faster. So right here we have actually a page component created as a functional component, and we are just exporting this page. So let's define the page props. For each page we will deal with the index and the title. So let's specify right here that the page is a React functional component with these page properties, and let's take the index and the title. So right here we need just to deal with the page view. So here we go. We can already import the page from the components folder, and we need to provide the index and the title. So everything is fine right now. Of course, we are not seeing any changes in the simulator because we need to provide some styles to the page component. So let's specify the flex1 property and the background color as red. So I think we can get rid of the align items and the justify content property from the styles.container. So here we go. So if you have already watched some of my previous videos, you probably know that I usually like to use a different syntax for the background color. I use a lot the RGBA notation, and I like to provide the same blue color to each page by updating just the opacity. So the opacity will depend basically on the index. So what will happen? Basically, the first page will have a blue color with a 0 opacity, so it will be basically a white, though the first page will have a blue color with 0.1 opacity, and the third page will have basically a 0.2 opacity, and so on and so forth. So usually I like to start with a +2 offset, So therefore, the first page will have a 0.2 opacity instead of a 0 opacity. So we can see that everything is working fine. So of course, we want actually to deal with the different pages. So the page will cover all the screen, but we will fix this kind of stuff later. Right now, let's try to focus on our PanGestureHandler. So first of all, let's wrap the pages with the PanGestureHandler component. So right now, React Native is complaining because we need actually to wrap a single child with the PanGestureHandler. So we need also to wrap an animated child when dealing, an animated component when dealing with the PanGestureHandler. So let's wrap an animated view, and the animated view will contain all the pages. Let's specify the style as flex1. So, of course, we are importing animated from React Native, a Reanimated package. So, since we need to deal with the horizontal scrolling for this tutorial, let's specify right now the flex direction as row. So here we go. We will fix later basically the page width for each page. So let's try actually to handle the amount that we are translating on the horizontal axis. So in order to access this value right here, we need actually to use the PanGestureHandler and to handle the onGesture event property. So let's start by defining a PanGesture event. This PanGesture event will be equal to useAnimatedGestureHandler hook. So I've already defined, actually, I've already used in some of my previous tutorial this hook right here. So I will provide in the video description some link related on this hook. So I've already created a PanGestureHandler basic tutorial and a PanGestureHandler basic tutorial where I actually use in depth actually this hook right here. So let's assign the PanGesture event to the onGesture event property of the PanGestureHandler. So of course, right now nothing will change. With the useAnimatedGestureHandler, we can access some callbacks. For this tutorial, we will need the onStart callback, the onActive callback, and the onEnd callback. So since we are dealing with a PanGestureHandler, it is a good practice always to specify with the useAnimatedGestureHandler the type of our handler. So in this case, it is a PanGestureHandler, therefore we need to specify the PanGestureHandler gesture event type. Otherwise, for instance, if this was a PanGestureHandler, in this case we will have a PanGestureHandler gesture event. So let's going forward and let's try to access actually the translate x value. So we can access this value with the onActive event object. So we can log actually the event.translationX. So when we scroll, we can actually see right here that the PanGesture event is logging correctly actually the translate x value. So this value is pretty useful, and it is much more useful to store this value in a specific shared value. So let's define a translate x shared value with the initial value 0. So translate x will be a shared value of type number. We can actually update the translate x value with the event.translationX property. And since we want actually to handle all the translation in the page component, we need to pass the translate x shared value to our page component. So let's specify right here the translate x shared value. So right now, TypeScript is complaining because we need actually to specify the translate x property in the page props. So let's say animated.shared value of type number. So here we go. and we can access our translate x value. So what is missing right now? Right now we need just to actually translate our pages with this translate x value. In order to do that, let's define the reanimated style with the hook useAnimatedGestureHandler. Let's return a style with the transform and with the translate x property that depends actually on the translate x value that we are passing to the page. And in order to pass this reanimated style to this view right here, we need to deal with an animated component. Therefore, we need an animated view. So here we go. So we need to pass right here the reanimated style. And let's see if something is working. So right now we can see actually that everything is working fine. We can actually try to fix right now the page width of our pages. So a good way to deal with this in this specific case is to use the stylesheet absolute fill object. So the stylesheet absolute fill object will put each page on the top of each other. So we need actually to, we can see that actually all the pages are on the top of each other. So we are not able to see the pages right here. And we need actually to displace, to provide an offset to each page in order to actually avoid this kind of behavior. So we will see right now what I'm talking about. We need actually to provide a page offset. The page offset depends on the page width. So actually the page width will be equal to the entire screen width multiplied by the current index. So let's just define our page width. So let's use the dimensions API from React Native. We can access the screen width and we can assign the screen width to our page width variable. So let's translate also the animated view with this offset right here. So we can actually see that right now it is working, but why it is working? It is working because we are displacing the first view with an offset equal to 0, because the first index will be equal to 0. The second view will have a displacement of page width multiplied by 1. The second view will have a displacement of 2, because the index will be equal to 2 multiplied by page width. And therefore, every page will be correctly displaced right now. So we can see that everything is almost working fine, but there's still an issue. When we translate, every time we can see that the animation is restarting from value 0. So basically, every time that we are translating, the animation is starting from this value right here. So we need to find a way to store and to store our previous value and to retrieve our previous value. So thankfully, with the Reanimated package and with useAnimatedGestureHandler, we can access another object right here that is called context. So this context object can be used to pass basically a value between these callbacks right here. So basically, here with the onStart callback, we can access the context object. And we can say, for instance, that context.x is equal to translate x.value. And we can retrieve right here the context.x. So basically what we are doing, in the onStart callback, we are storing our previous value. So we are retrieving our previous translate x value. And in the onActive callback, we are calculating the next translate x based on the current translation x value and the previous translate x value that it was stored on the translate x value. So right now we can see that the TypeScript is complaining. So we need actually to specify the context type. So let's define right here the context type. So we will, it will be an object with just the x property. And we can specify the context type as a second type of the useAnimatedGestureHandler. So right now we can see that the TypeScript is not complaining about the context as before. So we can actually see that right now everything is working fine and the scroll behavior is almost perfect. But there's still an issue, by the way. And the issue is related to the fact that when we are scrolling and when we stop actually to scroll, the scroll stops instantly. So normally this is an issue because when we use a scroll view, by default we have a kind of deceleration when we stop our pan gesture. So in order to handle this kind of deceleration, we can decide actually to use a specific function from Reanimated that is called withDecay. So withDecay, we will actually handle this deceleration based on a velocity. So this velocity right here is the velocity that we are basically passing when we are scrolling. So when we scroll with a velocity, and this velocity is stored in the event object. We can access with the event object the velocity x. So I hope that is clear, but by the way, it is a very easy concept. It is just a little bit complex the first time that you see it, but by the way, it is really simple. So basically the withDecay is a kind of magical function because it is handling by default all the deceleration based on the velocity that we are passing. So we can see actually that everything is working fine right now. But there are still two issues. The first issue is related to the first page. So when we are scrolling and we are on the first page, when we are going from the first page to the left direction, we don't want actually to be able to scroll because this is not a page. So we want actually to clamp this value right here. Of course, we will have the same problem at the end of our list. So right here we can see that this is actually the latest page, and when we scroll after the latest page, we want actually that the value right now is clamped, so we don't want to be able to scroll. So my way to handle this kind of behavior, to avoid this kind of issues, is to define a new translateX value. So I will call it clamped translateX value that is basically derived on the previous translateX value. So right now we can actually make some kind of logic. We can add some kind of logic on this clamped translateX. So first of all, let's try to log actually the translateX value, and let's try to see what is the issue right now. So when we are on the first page and we are translating to the left direction, we can see that the translateX value became positive. But when we are scrolling to the right direction, the translateX value is negative. So we want actually to avoid the positive value in order to lock basically the translateX right now. So in order to avoid a positive value, we can see that the translateX value, the clamped translateX value, should be the minimum value between translateX value and 0. Therefore, when translateX value will be a positive value, the clamped translateX value will be equal to 0. So let's see if everything is working. So when we are on the right, when we scroll on to the right direction, everything is working fine. When we scroll to the left, everything is working as before, because we need actually to pass this clamped translateX value to our page. So this clamped translateX value is a kind of translateX value adjust. So let's see what is happening. So when we are scrolling, everything is working fine. When we are scrolling to the left, everything is working fine. But there's still actually an issue. So when we are scrolling a lot to the left, when we are retrieving actually our translate x value, the translate x value will be equal to a huge positive value. So we can see that anything will work, so nothing will work until the translate x has reached a negative value. So in order to avoid this kind of strange behavior, we can actually retrieve, instead of the translate x value on the onStart callback, we can retrieve the clamped translate x value. So let's see if everything is working. So when we are scrolling a lot right now, everything will work fine because we are retrieving this clamped translate x value that will start from 0, no matter what kind of value will have the translate x value. So the first issue is solved. We need actually to solve the other issue on the latest page. So in order to avoid this behavior right here, we need to deal with some kind of observation. So the first thing that we need to notice is that we want actually to scroll until a max translate x value. This max translate x value will be equal to page width multiplied by titles dot length. So let me titles dot length minus 1. So right now actually we need to handle this page width. The page width is provided right here. We need to export actually the page width from the page component, and we can import the page width right here. So the max translate x will be equal to page width multiplied by titles.length minus 1, because it basically the translate x value that we have right here. So since the translate x value will always be negative, the max translate x will be equal to minus page width multiplied by titles.length minus 1. So what we want actually that this value right here, so the clamp translate x should be equal to the max from this value, between this value right here and the max translate x. So let's see if everything is working. So we can actually see that we are not able to scroll after the latest page, therefore everything is working fine right now. So let's remove the log right here. Of course, we can define the max translate x right here, for instance. We are not forced to define the this kind of value in the useRide value. So everything is working as before. So our latest step is actually just to put our title in the middle of the page. So let's go to the page component. Let's wrap with the animated view text component from React Native, and let's put the title right here. So here it is. It is a little bit hide, so we need actually to center with the align item equal to center and the justify content property, and we can actually fix our text style. So let's use font size equal to 770, font weight equal to 700, letter spacing equal to 1.5, and text transform equal to uppercase. So everything seems perfect on this iOS simulator. But by the way, I've already tested this kind of scroll view on my physical device, and there's still an issue when you play a lot with your scroll view right here. So you can see basically the issue when you scroll, you have the decay, and you stop the decay, the deceleration. So I will put somewhere actually a video that is provide you more information on this kind of strange behavior. So you will see my physical device, and on the physical device you can actually notice that there is an issue when scrolling a lot and when stopping the animation. So in order to avoid this kind of behavior, we need actually to cancel the previous animation every time we start, every time we use again our pan gesture. So basically right here, I'm just putting the cancelAnimation function that is provided from Reanimated, the Reanimated package. And the purpose is that when the translateX value is updating with the withDecay function, and we are tapping again in order to handle the pan gesture, we need actually to cancel the animation handled by the deceleration, because we want to stop instantly the behavior of the deceleration when retapping actually on the scroll view. So I hope that the tutorial was clear, and thanks a lot for staying with me all that time. So if you are interested on the Reanimated topic, remember to subscribe to this channel, and if you have any suggestion or any video proposal, feel free to leave a comment in the section below.